A math class contains 5 females, 3 of whom speak French and the rest speak only English, and 7 males, 2 of whom speak French and the rest speak only English. Before we even start the problem, I'm going to make a table to organize this information. So I'm going to make the table on one side, I'm going to have females and males, and on the other side, I'm going to have French and English. So it says of the females, so in the females row, 3 speak French and 2 speak English for a total of 5 females. In the males row, 2 speak French, and there are 7 males, so the rest speak English for a total of 7. So first thing you should do is you should make a table like this and have the totals. 3 plus 2 is 5, 2 plus 5 is 7, 3 plus 2 is 5, 2 plus 5 is 7. Now part A says, a student in the class is chosen at random. If you're told the student is female, now automatically, because we're told that the student is female, we are only going to focus on the females. Okay, so we know that for sure that the student is female. That means we're only choosing from these 5 female students. What is the probability that the student can speak French? So we want to know the probability that the student speak French given that the student is a female. So we always start with the given. We're given that the student is female, and this is going to be your denominator. So how many females do we have? We have 5 females. Now we're only choosing from this green row. We're only choosing from the females. Of the 5 females, how many speak French? 3 of the females speak French. So our probability is going to be 3 out of 5. So the numerator always has to come from your denominator. Please remember that. Your denominator is a female, so we're only choosing from these 5 females, and of those, 3 of them speak French. Part B says the first student is placed back into class and another student is chosen at random. If you're told the student can speak French, what is the probability that the student is female? So now we're looking at it in a little bit of a different way, even though we get the same answer. So in this case, we are told that the student speaks French. So we're only looking at the French speakers. So we want to find the probability that the student is a female given that they speak French. So now we're looking at the students who speak French. Of the students who speak French, there's 5 of them, so our denominator is 5. How many are females? Once again, it is 3 females, so we get the same answer. Now, if they had asked you, what is the probability that someone is a male given they speak French, then you'd say, all right, how many students speak French? 5 students. Of them, how many are males? There are 2 of them. So that's how the answer would change. In this problem, we have a table that lists a random sample of 39 speeding tickets on a freeway. The tickets are split up by gender, male and female, and how fast they were going over the speed limit for totals. So part A says, if a random ticket is selected, what is the probability that the driver is a female? Now the probability is always the number of successes. So in this case, anyone who's a female, we define as a success, divided by the total number of people. So we have 11 females over 39, and that is your probability. Part B says, given that a particular ticket had a male offender. So now, given that a particular ticket had a male offender. So here's what that means. It means that we're only choosing from the males. Okay, so the offender was a male, so we're only choosing from these 28 males. So when we're given something, our denominator is restricted to that condition. So our denominator is only going to have these 28 males. Now, of these 28 males, how many were more than 20 miles over the speed limit? So of these 28 males, and we're only looking at the male row, of these 28, 11 of them were more than 20 miles over the speed limit. So our probability is going to be 11 over 28. Part C says, given that a particular ticket was 10 to 20 miles over the speed limit. So look at the given. The given is your denominator. And we're given that a particular ticket was 10 to 20 miles over the speed limit, so I'm only going to be looking at this column. Okay, so these drivers were 10 to 20 minutes or miles per hour over the speed limit. How many drivers were there who were going 10 to 20 miles over the speed limit? 18. So our denominator is going to be 18. Of those 18, and we're only choosing from this column of 18, how many were females? 8 of them were females, so our probability is going to be 8 out of 18. The next one says, if a random ticket was selected, what would be the probability that the driver was a male? All right, so in this case, we don't have a given. We just want to know the probability that the driver is a male. So we'll take a look at the total number of males. There are 28 of them over 39 total. So it's 28 over 39. If you don't have a given, then you're choosing from everybody. Part E says, if a random ticket was selected, what would be the probability that the driver is a female and driving 10 to 20 miles over the speed limit? So think of the word and as an intersection. So Santa Ana College is on Bristol and 17th. So this is Bristol, this is 17th, and then SAC is at the intersection of that, Bristol and 17th. So think of the word and as an intersection. So we're looking at how many drivers are female. So we're looking at all the females and driving 10 to 20 miles over the speed limit. Okay, so females are here, the 10 or 20 is here. Their intersection is going to be these 8 drivers. And because we don't have a given, we're choosing from everybody, so our probability is going to be 8 over 39. So when you have the word and, look for the intersection, look for where are females and the 10 to 20 miles per hour over crossing. They're crossing in this middle section, which is 8 out of 39. Okay, so and is intersection. Lastly, if a random ticket was selected, what would be the probability that the driver is a female or driving 10 to 20 miles over the speed limit? Now, the word or has a formula. The or formula is this. It's P of A, whatever event A is, plus P of B, whatever event B is, minus P of A and B. Okay, this is going to be, anytime you got the word or, that's called the addition principle. We're going to be using this formula. So in this case, our formula is going to look as follows. We're going to have the probability that they're female. The word or is plus the probability that they're going 0 to 10 miles per hour minus the probability that they're female and they're going 0 to 10 miles per hour over the speed limit. So first, let's take a look at how many females do we have. We have 11 females out of 39, so the probability of a female is 11 out of 39. Or 0 to 10 miles over the speed limit. So how many people are going 0 to 10 miles over the speed limit? That's 8 people. So we're adding the 11 females plus the 8 people going 0 to 10 over the speed limit. But then this got counted twice. Okay, so take a look at how we got to the 11. We got to the 11 by adding the 1 and the 8 and the 2. And then take a look at how we got to the 8. We got to the 8 by adding these. So this 1 got counted twice, once with the blue, once with the green. So we got to subtract off the 1 out of 39. 11 plus 8 is 19 minus 1. That'll be 18 out of 39. So the word or always is going to be P of A plus P of B minus P of A and B. And keep in mind that this and is the intersection of female and 0 to 10, which is going to be 1. A quick quiz consists of a multiple choice question with 6 answers, followed by a multiple choice question with 5 answers. If both questions are answered with a random guess, find the probability that both responses are correct. So because we're guessing, since we're making 2 selections, we need 2 probabilities. Okay, and then I kind of wrote over that. Since 2 questions are answered, we need a probability for each question. So question 1, we have 6 choices, and only 1 is correct. So the probability of guessing correctly is 1 out of 6. Question 2, we have 5 choices, and there's only 1 correct. So the probability of guessing correctly is 1 out of 5. And because we have 2 selections, we have 2 questions, we need 2 probabilities, 1 for the first, 1 for the second, and we multiply those together. So for the first question, the probability is 1 out of 6. For the second question, the probability is 1 out of 5. If you multiply these together, we get 1 out of 30. That's 0.0333 times 100. That's going to be 3.3%. We have a table split up by males and females, and those who received A's, who received B's, and who received C's. If one student is chosen at random, find the probability that the student got an A. So we look at all the people who got A's. There were 15 and a total of 55. So that's going to be 15 out of 55. Remember that probability is the number of successes divided by the total. Find the probability that the student was a female and got a B. Now the word and, it means intersection. So we're looking at the intersection of the students who are female and the student who got B's. So intersection, it means we're looking for the overlap, where they cross. And they cross right there in the middle, and that probability is going to be 7 out of 55. Find the probability that the student was a female or got an A. The word or, that's the addition principle, which is probability of A plus probability of B minus probability of A and B. So in this case, event A is that they're a female, event B is that they got an A, and then we subtract off the intersection. So first, let's take a look at how many are females. We have 20 females out of 55, so the probability of selecting a female is 20 out of 55. Or means plus. Plus, what is the probability of getting a student who has an A? So we have 15 students out of 55 who have A's, so that probability is going to be 15 out of 55. Now, some students got counted twice. Some students got counted with the females and with the students who got A's, and that's going to be the intersection of that, which is these 5 students. So we subtract off the 5 students who got counted twice. So 25 plus 15 is 35 minus 5. That's going to be 30 out of 55. Finally, if a student is chosen at random, find the probability that the student was male given they got a C. All right, so the word given, it means that we're only restricting our sample space to the students who got C's. So I'm only going to focus on these students who got C's, and everything else disappears. So we have a total of 14 students who got C's, and that'll be our denominator. Of the students who got C's, how many are males? So we have 6 males of the 14 who got C's, so our probability is going to be 6 out of 14. Every cereal box has a gift inside, but you cannot tell from the outside what the gift is. The store manager assures you that 16 of the 41 have a secret ring, and the other 21 they do not. If you select 2 boxes of cereal from the shelf to purchase, what is the probability that both of them have a secret decoder ring? So we're selecting 2 boxes. Selection 1, we have 16 um, boxes that have a ring out of 41. Now, if you remove 1 box, instead of 16, only 15 have a ring, and instead of 41 boxes, only 40 have a ring. And anytime you make more than one selection, we need to find both probabilities and multiply those together. So we multiply 16 over 41 times 15 over 40. So that's probability that they both have a decoder ring, and that'll be 0.1463.